Welcome back to the garage.
So what we're making today is a drawbar for the milling machine. Basically all this is it goes through the head of the mill and it grabs the tool underneath, and as you thread it in, it draws it up into an internal taper which holds your tool in place rigidly. The problem currently is the mill I have is from China and the thread on this is metric, and I'm in Canada. Now the thing is, Canada in theory uses the metric system, but it doesn't really. What we did instead is we joined, because we're so inclusive, we joined every single measurement system on earth. And if you go into like a Home Depot, they're all there. I joke with people that when I need a drill bit, in theory Canada runs on metric, but you have M, like millimeter size, you have inch decimal, you have inch fraction, and then you have of course number, so you have like a number 1 drill bit. There's letter too. I've learned about that recently when I was looking at metric charts, because I need a specific drill bit size for something, and I was looking at like a chart diagram for different drill bits. So there's drill bit number, of course there's gauge. Every time I try to design something, I should bookmark it. I have like millimeter to inch decimal, and then inch decimal to inch fraction, like calculators up on my second monitor, because constantly I have to try and figure out what I'm gonna need to make these things, because it's a complete nightmare. Anyway, I need this to be a 7/16 by 20 UNF, and it is an M12 by I think 1. So basically all I have to do is remake this and put a different thread on it. I could maybe rethread this, but then I wouldn't be able to use the tooling that the machine comes with. So now you can buy these on, I think My Little Machine Shop sells them, but the problem with that is it's like a little company and it's gonna come in from the States, and there's me like import stuff and it's gonna take a while. So I just decided to make one of these because I needed a lathe anyway, and I knew that would come up at some point. That's guy math for you. I need this thing, it's $30, but I'll just buy an expensive lathe and learn machining. Also, I wouldn't know that this is for sure the same thing as in my mill, and if I do it myself I will, because the thing about these Chinese mills is they kind of all come from like one foundry that makes that shape, which is why if you want to learn how to like service something like this, you just type in Chinese mini mill, because like if you try and find the brand you bought, you probably won't get it, because there's like 400 little brands that finish these castings into machines. But if you just find basically the same body, it'll probably work. Any like modification or maintenance you have to do on it. So I have this drawbar and I need to make another. So I start by loading a bar of 4140 into the lathe. Here I face it off so that I can drill the center. Here I use a centering drill bit to put a support hole in the stock. Now that the bar is supported, I turn down the entire diameter to make sure it is concentric to the chuck. Now I turn down the threaded portion. Once the threaded area was complete, I had to turn down the half-inch section of the bar. This was less than thrilling. Finishing the shoulder. The last job on the lathe is to undercut the threaded area. Now I know a lot of people like to sand under power, but I've seen enough videos of people getting sucked into a lathe that I'm just going to waste some time here and do it by hand. So, I do have a threading tool for the lathe, and that lathe can be set up to single point cut, but I haven't fully figured out how to do it yet. The instructions are present. The thing is, threading dies aren't a standard size. They're whatever the manufacturer wants them to be, it would seem. So this tool comes with 3 adapters for threading die, and no, and like hot dog meat hallway. So what I had to do is go to the lathe and put the die in a die wrench and basically just press the tailstock up to it so it would cut straight. Footage here. So now I've got this die done, it's time to cut the flats. So to do that, I will have to do math, which is scary. You can actually hear my my brain heat up, and it starts like sizzling like bacon grease when I have to do basic addition. So this is going to take a little bit, but basically I will have to get the depth to center of this and the difference of here to the flats, and with that I should be able to do layout and cut the flats accurately. I mean, they don't have to be that accurate, but what's the point of machining stuff if you're not going to do it properly? But before we go any further with this, I want to tell you all a story of my first lathe, because it was a disaster. So, around February, I'm gonna say, bought a lathe, and it showed up. Everything was normal. I unpacked it. The crate basically self-destructed when I did that. It was like this awful particle board stuff. It wasn't even proper plywood. Anyway, I plugged it in, it doesn't turn on. Now, I contact the manufacturer, Vivor, and they get back to me. So here's the thing. I don't know anything about electronics. I've made like a couple little things with like wiring projects, but I need a detailed video guide to do anything of any significance. So there I am, looking at this thing that won't turn on. I take out the back plate. I'm sending them pictures. I'm sending them my troubleshooting videos, and they're sending back like pictures of the motherboard, let's say, with like an arrow on it that says like test these. I don't know what that means. I get more information. It's like I need to get this thing. I don't know what it's called right now. You put the two poles. Okay, Home Depot just calls it an electrical tester. But it has the little readout, and you stick the pins and you look at the screen, and it says how much juice is flowing through the whatever. So I do that. They tell me I did it wrong. I ask for more clarification. They say just test it, that's helpful. Back and forth for a while. I'm unsleeving like connectors that I'm not sure how I'm going to re-sleeve them. I'm checking voltage, all this sort of stuff. And the thing won't turn on. And the thing is, I have about 30 days to either accept this product or return it to Amazon. So at about the 20-day mark, I go, this isn't really happening. I need like a clear guide, or this is meant to go back. So what they reply with, very apologetic this whole time. They're customer service people, but they're not like helpful. So they just say, well, there's a circuit diagram on the back, on the machine. They say just consult that, just follow the circuit diagram. I don't know how to read a circuit diagram. I tell them, I'm a blacksmith. They just say, no, just read the circuit diagram. It'll tell you how to fix it. And it's like, well, okay, this is going back, because you might as well tell me, like, here's the rocket diagram, make one. Like, I don't know. I want to swear, but I shouldn't. It's YouTube. Let's just suffice it to say I don't know how to do that. So I go to send it back to Amazon. Next hurdle. you would assume that there's some way to get in touch with Amazon customer service. You probably think that. You probably think there's like, you go to customer service, there's like a little pop-up or a phone number to call. There isn't. I implore you to go check. There isn't. At least when I did it, I like look up how do you get in touch with a customer service representative, and there's guides, like guides in the same way as like installing Skyrim mods or trying to fix like a graphical issue on your computer. There is no clear way to accomplish this, and the comments are full of people going, guide didn't work, like I don't know how to get in touch with Amazon. What it has is like a menu that you go to, and it's like your problem, and it drops down and like, try this, can we do this, like here's a form, all that sort of stuff. But there isn't a form for, I need to return my mini lathe and the box is destroyed because it came in a big crate that was made of basically styrofoam wood. There's no form for that. So I need to contact someone from Amazon. I can't contact someone from Amazon because it says you have to put it on your front porch or whatever with the box. There was no box. The box was destroyed. It's a lathe. It's not, you know, a pair of shoes or whatever I ordered. This is the problem with not having a customer service person and just having machines run everything, is machines aren't very good with edge cases. You need people for that because machines have like, oh, this is the stuff that normally happens and this is how we deal with it. Well, this isn't a normal situation. And if you're gonna sell unusual things like lathes, you need to have a way to deal with this. I know, Jeff is crushed by this news. Anyway. So basically what I had to do is I just say, come get it. You know, this is the situation, just return it. It's on the front porch. Knowing that they probably won't take it. It's not in a box, but I need to talk to someone who like can answer a question. So I'm just gonna have to waste their time. So they come over and they looked at the thing and they go, well, it's not in the box. I'm like, okay, I hear you. What constitutes a box for this? Does it have to be in a crate? Do I have to build a crate? Do I have to do something like that? Can it just be cardboard, even though that would last like 3 seconds holding this thing? And does it have to be the original box because the original box is in a landfill? The guy goes, a box. Just Google box in Wikipedia, the picture shows up. If it looks like that, it's good, don't care. So I go to Home Depot and me and my dad get like the cheapest plywood on earth and we build this, like nail together this coffin for the thing and we put it on the front porch. Okay. So now this thing has cost me money, because obviously I'll get the money back, but I had to pay for the plywood. Now you can say don't throw out the box. I didn't with like this one. I still have it on hand, but it was destroyed. Like my mill and this lathe came in a crate that was like disassemblable, right? It was made of plywood, cheap plywood, but plywood. The thing the other lathe came in was destroyed in the process of taking it apart. It would be unsafe to have someone handle it if I tried to, like it'd be glue and duct tape holding it together if I tried to recreate it. So I just threw out that wood. Anyway, I put it back out and they take it away and they get my money back. But that was a process. That left a sour taste in my mouth, and I still needed a lathe. But I couldn't get back around to buying one until about, I think it was June I got this, because I was just too annoyed with the whole process, but I still needed one. So I got this lathe and it seems fine. This has been my TED Talk. Here you can actually see the moment that the machine flings a piece of hot metal into my mouth. Okay, so that's a wrap. I have successfully created a imperial version of this drawbar. I'm pretty proud to say that I have to look at them for a second to tell which one's which. The main thing is that the threads, they look quite different. I was actually worried that I would have a hard time figuring out which one was which, but the threads are visibly a different pitch. The only change that I made was I made the flats for the wrench a little bit longer. I thought this was a bit short when I was trying to tighten this, and I also heat treated the end. It's my understanding that you generally don't heat treat bolts, which this essentially is. So I just heat treated these, or this end, so that the nice crisp edges won't roll over when I go to tighten this thing. And then I tempered it to blue. So it should be very strong and solid. If you liked the video, go ahead and subscribe. There's going to be more machining content around here. I've been enjoying my mill and my lathe, and I will see you in the next one.